Now, after these devastating earthquakes, one of the main concerns was to learn how the hospitals with base isolation behaved or survived during this earthquake. And now, Dr. Bahadur Shahdan, who is the current president of TASI and also a faculty member in the Civil Engineering Department of MEF University, will talk about the performance of hospital structures in special with base isolation during the earthquake.
Thank you very much, Dr. Erberik, and hello everyone. I will show you our site observations of seismic isolated hospitals after Kahramanmaraş earthquakes. Well, some of the photos you might see might be a little bit surprising because we also observed some minor damages, and I will show these as well. These are the list of hospitals in the region close to the epicenter. You know, the first earthquake happened in the south, then it went towards the north, and there are 11 hospitals. Actually, we could also count Elazığ Hospital, one of those. There are 11 hospitals in the region that we visited after the earthquake. And we started our travel from north to the south. So the order would be something like this. The reconnaissance team was formed by the members of the Turkish Association for Seismic Isolation. It was a 3-day trip with my colleagues, Dr. Cüneyt Tüzün, Ömer Ülker, Mehmet Emre Özcanlı, and Uğurcan Özçamur. We visited these hospitals in 3 days of time. It was a little bit hard times for us. We couldn't find safe places to sleep. One day we stayed at one of the seismic isolated hospitals, inside one of the seismic isolated hospitals. The other day we slept at the construction site. And I would like to give my special thanks to the SIE team. They are also members of TASI, Turkish Association for Seismic Isolation. They did a really good job to prepare a report, data sheets for each hospital. And I benefited from those data sheets in my presentation. I'm going to start talking with the one on the most north part of the area, Malatya Battal Gazi State Hospital. In all of my slides, there is the similar pattern. You will see the hospital information, the location, the nearest station, the hospital's distance to the main shock. I mean, the first earthquake, magnitude 7.8 earthquake. It is, as you can see, it is a little bit far away, but the second earthquake was closer to this hospital. And these are the records selected from the first earthquake from the nearest station. This hospital has 300 beds capacity, and it has 10 stories with a reinforced concrete frame and infill walls structure. There were 222 double pendulum bearings with a displacement capacity of 450 millimeters. The structural engineer is the Bensum Engineering Company, and the isolator manufacturer was the local isolator manufacturer of Turkey, TIS. Let me talk about the observations. Actually, in this hospital, isolation worked effectively, and hospital operation was not affected totally by the earthquake. It was one of the most successful hospitals in the region. The hospital operations were ongoing, and the building was also serving as a shelter. When we went there, we found out that the locals were staying overnight in the hospital. All our findings, I mean, these displacements are from our observations on the site, whether checking inside the isolators with horoscope, the dust swept, or checking the marks around the building. So from the boroscope readings we saw in the isolators, the friction pendulum isolators here, we found that the maximum isolator displacement was approximately around 17 centimeters, and we also found the residual offset of 1.5 centimeters. We didn't observe any damage to the isolation bearings or connections. We didn't observe any damages to the utility or piping systems crossing the isolation plane. There were some minor cracking observed at joints between structural framing and non-structural partition walls. Actually, this was very common. We found this kind of cracks nearly at all isolated hospitals. And you can see a pattern here in the suspended elevator staircase, where you can see the crack between the infill walls and the reinforced concrete members. This is a photo from the outside of the hospital, and this is a photo from the exit of the emergency, where you could see that the moat was covered with both snow and also You will see in the next photos much better in the following hospitals with the pumice stones inside, and the cover was something like this on top of the moat. The second hospital was very close to the first hospital we visited, the Malatya Battal Gazi Hospital. This hospital is just a few kilometers away of that hospital. You can see that nearly from all the response spectra, the spectral accelerations are sometimes closer to the MCE event, MCE based design response spectrum, or sometimes even higher in the long period range. This is the hospital, the structural engineer is Prota, and again, the isolator supplier is the local isolator manufacturer TIS. There were 246 double pendulum isolation bearings with a displacement capacity of 360 millimeters in that hospital. This hospital has some problems. What kind of problems? First of all, when we visited the hospital was in operation during our visit. We found out that the isolator displacement was around 4 centimeters. Previously, the hospital that was very close to this hospital had an isolator displacement around 17 centimeters. This had 4 centimeters only. The reason behind that was the improper details around the building. For example, in this photo, you can see the soil retaining wall near the entrance of the building. This retaining wall, reinforced concrete retaining wall, was just very close, adjacent to the isolated slab. So during the earthquake, it prevented the isolated slab to move. And therefore, we saw some non-structural damage inside the building, some damage to the walls and suspended ceilings. And but we didn't observe any damage to the isolation bearings or connections, and nor we didn't see any damage to the structural members as well. There were no damages also observed to the utility or piping systems crossing the isolation plane. This was a photo from the basement floor where you can see the isolators over on top of the columns. And here you can see infill wall improperly connected to the isolated superstructure. Therefore, due to the lack of moment joint, the basement wall cracked. The third hospital was that we visited was Malatya Doğanşehir State Hospital. Actually, this hospital was the hospital with the severest damage, non-structural damage due to the earthquakes. The spectral accelerations might seem a little bit low, but as I said, these spectral accelerations are from the first earthquake, which was quite far away from the epicenter of this hospital. The structural engineer is Ülker Mühendislik. Again, the isolators were provided by the local isolator manufacturer. There were 122 double pendulum isolation bearings with a displacement capacity of 490 millimeters. This is a view of the hospital, and this is a photo from the isolators. There is a very small residual offset that is visible around 1 centimeter. The maximum isolator displacement that we observed was around 9 centimeters. The hospital operations were disrupted by the earthquake damage and not in service at time of the inspection visit. And we didn't see any structural damage. We didn't observe any damage to the isolation bearings or connections, but there were some non-structural damage. What were those damages before passing there? These damages were mostly damages due to the unrestrained partition walls that toppled over the suspended ceilings. I mean, when they were constructing those partition walls, they did not connect on the superstructure. They did not connect the partition walls to the next story, the next floor. And there, after the false ceilings, walls were not connected, and they were cantilever. And due to the vibrations occurred, those brick walls toppled down on the suspended ceilings and created a damage. The second reason of the damage was due to a retaining wall that was adjacent to the isolated floor. And you can see the damage created by the heat of the isolated floor to the retaining wall. Actually, this part was constructed later on, and this part is a brick, and this part is reinforced concrete. This is a photo from the perimeter, moat perimeter. Actually, the moat was all filled with the debris and also soil. There was no moat there, so the movement of the hospital was interrupted, and the result inside was something like this, the suspended ceiling damage. As I said again, I'm repeating it, the main reason of the damage was the toppling of the walls over the suspended ceiling that were not connected to the upper story, and they toppled down on the suspended ceilings and created this damage. The next hospital we visited was Kahramanmaraş Elbistan State Hospital. Actually, this hospital is very close to the epicenter of the second earthquake, but these records are from the first earthquake. the hospital is constructed over rock soil, so the vibrations were not that much higher like the other hospitals. The structural engineer was protein engineering. The isolator supplier was different this time. It was Italian manufacturer FIP MAC. There were 455 double pendulum bearings with a displacement capacity of 300 millimeters. The hospital was in operation and it was not affected by the earthquakes. Overall, seismic isolation system and movement detailing all functioned well. We can state that the maximum isolator displacement that we observed from the dust swept was around 4 centimeters, and there was a residual 1 centimeter offset that we saw from our observations, but this residual offset might be maybe prior to the earthquake due to shrink and creepage. We don't know, but there was a 1 centimeter residual offset. There were no damages in the building, some minor damage to tile work at front entrance movement joint, and some minor cracking observed at joints between structural framing and non-structural partition walls. These are the damage to the tile at the entrance of the building because tiles were just put adjacent to the isolated floor. There were some damages. Again, some damage to the tiles at the emergency entrance that we could observe. The next hospital was in Kahramanmaraş city, Kahramanmaraş Maternity and Children's Hospital. This hospital was under construction at the time of the visit, and the construction was around 20 to 30% of the total reinforced concrete construction, let's say. The structural engineer is Ülker Engineering, and there were 361 double pendulum bearings used in the hospital. The main supplier was, again, local manufacturer TIS. The capacity of the isolators were 1,000 millimeters, 1 meter. And when we check this hospital, these, first of all, isolators had shipping locking balls attached. And due to the movement of the superstructure, isolated superstructure, these balls were bent and broken. The maximum isolator displacement was approximately around 16 centimeters, and we saw a residual displacement around 4 centimeters. And we think that the reason of this residual displacement was due the unfinished construction over the isolators and the lower loads, axial loads over the isolators that created high friction forces, made the isolators not return to the recenter to the original position. These are some other photographs. You can see that the balls, shipping balls were broken, and there was a residual displacement of around 4 centimeters in the isolators. You can see that the team is trying to calculate the displacement with the boroscope. The other hospital that we visited was Adıyaman State Hospital. This hospital was under construction as well at the time of the visit, but it was about to be finalized. The structural engineer is Prote Engineering. The isolator supplier is again the local manufacturer TIS. There were 264 double pendulum bearings used, and with displacement capacity was around 350 millimeters. Reinforced concrete frame and infill walls were completed of this construction, and exterior cladding and internal partition walls were in progress. We observed isolated displacement around 12 centimeters, and there were around 2 centimeter residual offset. Design of moat and seismic clearances were okay, but some perimeter locations restricted with soil infill and construction debris. Probably these would be cleaned before prior to the hospital getting in service. There were some out of plane failure of some unrestrained internal partition walls, but there were no damages observed to exterior cladding or window systems. Here you can see the displacement observed around 12 centimeters in the moat, and the moat was filled with construction debris and also soil during our visit. Again, very similar problem. One of the retaining walls were constructed very close to the perimeter joint, so during the earthquake, they hit together and created a damage here. One other hospital is Osmaniye Düzce State Hospital. We are going to the south, and we are right now starting from Kahramanmaraş earthquake. We are closer to the epicenter of the first earthquake. Osmaniye Düzce Hospital was again under construction during our visit. The structural engineer is Neosys Design, and the isolator manufacturer is again the local manufacturer, TIS. There were 206 double pendulum bearings used in this hospital, and their displacement capacity was around 590 millimeters. There were no damages, including non-structural elements in this hospital. There were good seismic detailing in infill wall and suspended ceiling applications, not similar to the other hospital applications. We found good seismic detailings in this hospital. The maximum isolator displacement was around 8 centimeters, but as I said, there were some problems with the moats filled with soil and also retaining walls close to the perimeter joint. So probably this displacement would be much higher than 8 centimeters if it was free. And these are some photos from the perimeter joint. And again, construction debris restricting the movement at cover perimeter. One other retaining wall, again, constructed just near the isolated floor. So the movement was again restricted. The next one is Osmaniye State Hospital. It was just about to be opened in service. It has a bed capacity of 600. It has 600 bed capacity. Structural engineer is my company, OBS, Earthquake Engineering Solutions. The isolator manufacturer is TIS. There are 541 double pendulum isolation bearings in this hospital construction, and the displacement capacity of each bearing was around 450 millimeters. Just different than the other hospitals, there was a scratch plate. There were 2 scratch plates installed in this hospital, but we believe that there were problems in the scratch plates because the movement observed was only in one direction and it was only 4 centimeters. You will see that from the perimeter joint, from the infills in the moats, we observed more displacement around 12 to 13 centimeters in this hospital. There was a monitoring system included in this hospital, actually, but they were not in service during the earthquakes. None of the hospitals that we've previously visited had structural hand monitoring systems, but this hospital had, but unfortunately it was not in function at the moment. From the CCTV records, we saw that unfastened electric box at roof level overturned during the earthquake. There were some damages to the mechanical pipes between isolated building and the non-isolated car parking place due to the incorrect function at flexible joints. This is the moat cover that we generally observe in the constructions. It is pumice stone, and normally it is a very soft and light infill, but I think that this is improper infill material. You can see that there are around 12 to 13 centimeters of from the movements here. The next hospital is Hatay Dört Yol State Hospital. It was very close to the distracted area, but this area, Dört Yol area, the buildings around Dört Yol district were not that much affected from the hospital because soil conditions were much better than Hatay city itself. The structural engineer is Neosis. The isolator supplier is again the local isolator manufacturer TIS. There were 340 double pendulum bearings used in this hospital with 400 millimeters displacement capacity. Isolation worked effectively on the hospital, and the hospital operation was not affected by the earthquake. There were no structural damages. Very minor non-structural damage between column framing and partition walls, as we observed at nearly all hospitals. There were no damage to other utility systems. Maximum isolator displacement that we could observe from the boroscope observations were around 3 centimeters, and there was a residual offset of 1 centimeters, and building did not have any electronic seismic monitoring system. The moat covers are quite proper in this hospital, so no problem was observed. The next hospital is Adana City Hospital. This is the only hospital in the area with triple pendulum isolators adopted. There were 1,552 triple pendulum bearings that were manufactured by EPS. The structural engineer is Ülker Engineering. It's a huge hospital covering more than 300,000 square meters of area. When we actually the peak ground acceleration in this neighborhood was very low, but as you can see, the acceleration levels in the long period range were quite high near the hospital area. We did not, and the hospital, first of all, the hospital was in service after the earthquake. We just saw some displacement in the inner pack of the triple pendulum system, around 3 centimeters of displacement. All detailings of the seismic joints and clearances were okay. There were seismic monitoring system, but they did not share the results of the seismic monitoring system with us. But as far as I know, they shared these results with the isolator manufacturer. They can be found. There were no damages to partition walls, suspending ceilings, or utilities crossing the isolation plane. We saw some cracks to the at the grout below the isolators. This was very common nearly all isolators, but those cracks were not going deeper under the isolators. So probably these cracks were not due to the earthquakes, we believe. These are the seismic joints around the building and also inside the building. This is the elevator stairway shaft. You can see the seismic joint. And the last hospital, sorry that I took lots of time. The last hospital is Adana Güney Seyhan Hospital. We were not allowed to enter this hospital. We just made our observations from outside. The structural engineer is Neosys. The isolator supplier is FIP MEC. There were 251 double pendulum bearings with a displacement capacity of 235 millimeters. Again, you can see pumice stone as a mode fill, and there was a problem with the, again, perimeter joint, which was blocking the isolated superstructure. I come to the conclusions. The seismically isolated hospitals in general performed very well compared to the conventional buildings in the earthquake region, compared to the buildings around them. There were no structural damage at any of the isolated hospitals. There were some non-structural damage observed, but these non-structural damages were due to the poor design detailing, bad workmanship, especially for walls, and inadequate clearances at seismic moment joints. Flexible structures, mostly frame systems with no shear walls, are more susceptible to infill wall damage. We observed this kind of damages with mostly with flexible superstructures. Definitely further analysis is needed to thoroughly understand the detailed behavior of the isolated hospitals. We will do this and we will share our findings in the conferences in November. Structural hand monitoring systems are crucial to understand the performance of the isolated structures. None of these hospitals had structural hand monitoring systems that were in service. Seismic moment gaps and mode cover details need to be especially designed. Seismic bracing for suspended ceilings and mechanical electrical plumbing systems are necessary, in my opinion, even in the isolated structures. And building occupants should be informed about seismic isolation and expected movement, and building users should understand the importance of maintaining seismic movement clearances. Thank you very much, and hope to see you in the next World Conference on Seismic Isolation and the International Conference on Earthquake Engineering and Seismology. Thank you very much.
Thank you, Dr. Shadan, for this very informative presentation.